Hello everyone. Today you are welcome back to Jewel Study World once again. Today our lesson will be on covalent bonds. We have already learned about ionic bonds. For this topic, you have to note that the atoms don't transfer electrons, unlike the ionic bonds where electron is transferred. For covalent bonds, the electrons are shared between the atoms. The atoms share electrons to become stable. Note that the reason why they even form this bond is that they want to become stable. So here the atoms share electrons to become stable. Let's check our first example. We have the hydrogen molecule. The symbol is H2. You have to note that for covalent bonds, the bond is between two nonmetals or two or more nonmetals, or the atoms involved in this bond are only nonmetals. And for the ionic, it's a metal and nonmetal. So this is one of the difference between a covalent bond and ionic bond. So you have to know that it's the atoms that are bonding should be only nonmetals. So you have H2, so two atoms of hydrogen. So you have one atom of hydrogen. Here's the nucleus. It has the protons and the neutrons for the nucleus. It has only one electron. The same thing here, you have two, so one also here. You have the neutron and the protons. Here's the nucleus. So this is hydrogen, this two is hydrogen. So you have the nucleus here, the nucleus here. Each of them has one electron and one shell. So since they have one shell each, how would they be stable? They will only be stable if they follow the duplet rule or the duplet structure. For duplet structure or duplet rule, it states that for an atom with only one shell, it can be able to be stable only if it has two electrons. So this hydrogen atom has one electron, so it has to gain one electron to become stable. The same thing applies to this one too. So this atom will go to this atom and then tell it to give its electron to him. So it will be like, give me an electron for me to be stable. And the same thing, this will also tell this to give its electron to become stable. Now there will be a fight between them. One will say, give me an electron. One will say, give me an electron. So now, how will they become stable? Their mother will come to them and tell them that, why are you guys fighting? Why don't you share the electrons? So now, if they share the electrons, if this electrons is shared among them or between them, this guy will get two electrons and then this guy will get two electrons. Now they will become stable. Note, they are both nonmetals. Hydrogen is not a metal, so they are both nonmetals. So this is a covalent bond. So now if they share the electrons, this guy will get two electrons, then the duplet rule will be fulfilled. Then this guy also will get two electrons, and the duplet rule will be fulfilled, and they will become stable. All of them will become stable. So now let's draw the structure. It will be something like this. So we have this H, and then we also have this H. So when they share electrons, it becomes something like this. So you have H here and H here. Now this H atom or this hydrogen atom will have two electrons, and then this atom also have two electrons because they are sharing electrons. So these electrons are for this, and then they are also and at the same time they are also for this atom. Now you get H. So this will be a covalent bond between these hydrogen atoms. So what this is, so the electrons here are called shared pair of electrons. So they are shared pair of electrons. They are shared pair of electrons. And this dash here is also called single covalent bond. So this dash here is showing the covalent bond. Since we have only one of the dash here to become single covalent bond between these atoms. Note that one shared pair of electrons will form one single covalent bond. So we have, let's draw the dot structure. You have H here and you have H here. So this H has one electron here. So they are bonding. This H also have one electron here. So how will they share the electrons? So this guy will come here, they will lie side by side, and then this guy also will come here. So now we have this H with 2 electrons. Now this is stable because it has 2 electrons in its last shell. Now this has fulfilled the duplet rule. And this also has 2 electrons because the duplet rule states that for an atom with one shell, it should have 2 electrons for it to be stable. Now they are both stable. Since we have just a pair of electrons, a shared pair of electrons, we have just one covalent bond. Note that 2 electrons will form a pair of electrons. So we have one shared pair of electrons. Let's check another example. So let's check this example. We have oxygen molecule. So the symbol is O2. Note that we have 2 atoms of oxygen. So these are the diagrams of oxygen. Let's draw the configuration. We have 2 here, and you have 1, 2, 3, 4, 5, 6 in the second shell, 6 electrons. The same thing applies to this. So now, since it has more than one shell, it should follow the octet rule, which states that the last shell should have 8 electrons for it to become stable. So now this guy has 6 electrons in the last shell, and this guy also have 6 electrons in the last shell. So this guy will tell this guy to give it 2 electrons. This guy also will tell this guy to give it 2 electrons for it to become stable. Now their mom will come and tell them that, why are you guys fighting? Why don't you share the electrons to become stable? Now this guy and this guy will share these electrons. Now when they share the electrons, this guy will get 8 electrons and this guy also gets 8 electrons in the last shell. And they all follow the octet rule. So let's draw it showing only the last shell. So we have oxygen here with 8 electrons, 6 in the last shell. So we have 1, 2, 3, 4, 5, 6 in the last shell, only the last shell. And this one too, oxygen. Showing on the last shell, 1, 2, 3, 4, 5, 6. So now these atoms will form a covalent bond by sharing the electrons. So when they share electrons, this atom gets 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now this is stable. And this atom also gets 8 electrons. So we get 1, 2, 3, 4, 5, 6, 7, 8. So now this is also stable. They have 8 electrons each. So we get 2, 8, 8. We get 2, 8 here, and then 2, 8. So now they are both shared electrons, they become stable. So we get one atom of oxygen here with 8. 1, 2, 3, 4, 5, 6. 6 here. And also get one here with 1, 2, 3, 4, 5, 6. So you get 6 electrons in the last shell. For them to become stable, they have to share electrons. So you get 1, 2, 3, 4, 5, 6, and then this one too. You get 1, 2, 3, 4, 5, 6. So now you have 6 electrons and 6 electrons. They want to bond. So this is oxygen and this one is oxygen. They want to become stable by sharing electrons. So when they share electrons, this guy will get 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and this guy will get 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Now they have both fulfilled the octet rule by sharing electrons. So now, how many shared pair of electrons are here? We have 2 pair of electrons. This is 1 pair. This is 1 pair. So you get oxygen here and oxygen here. Since we have 2 pair of electrons, you get 2 covalent bonds. So you get double covalent bond. In oxygen, we have double covalent bonds. So now they have both fulfilled the octet rule. Now they are all stable. So this is why we get the structure of oxygen, or the symbol of oxygen, to be O2, because it has two atoms of oxygen. Now you have double covalent bond. Double covalent bond. Since we have 2 shared pair of electrons. So now this is how atoms form bond by sharing electrons. So now we will continue the part 2, or the second part of this lesson. Wait for it. This is Jewel's Study World. You are welcome to study with us anytime you want. Like and share my videos, and also subscribe to my YouTube channel. Bye bye.